Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider. You're watching Learn and Teach by Sir Ayaz. So I'm continuing my video session for O levels past papers, and this time I have selected IGCSE 0620, where it is 41 and it's of October, November 2024. You know the other details, it's of 1 hour 15 minutes. It's paper 4 theory extended version. You have to answer all the questions. You can use calculator in this paper. Periodic table will be provided in this paper. The total mark is 80. So let's start the paper. Here's question number 1. A list of chemical and physical processes A to H is shown. We have combustion, diffusing, melting, neutralization, photosynthesis, reversible reaction, roasting, thermal decomposition. Answer the following questions about processes A to H. Each letter may be used once, more than once, or not at all. State which of the processes A to H, A, happens when an acid reacts with an alkali. So when an acid reacts with alkali, its neutralization reaction takes place because the H positive ion from acid and OH negative ion from the alkali, they combine to produce water, and this is neutralization. So you write D for A. Part B, reaches a position of equilibrium. Now whenever a reaction, you can't have every reaction reaching to equilibrium position. The equilibrium position will reach in a closed system, and it's a reversible reaction that reaches to equilibrium in a closed system when the rate of the forward reaction becomes equal to rate of backward reaction. So answer must be F in this case. C, involves a particles changing from fixed position to being mobile but still touching. So it involves the particles changing from fixed positions to being mobile but still touching. It must be melting. So you write C here. D, are physical changes. So you have to pick the processes that are physical changes. Combustion is a chemical change. Diffusion is a physical change because it's random movement of particles from higher concentration to low concentration. Melting is also a physical change. It involves changing of solid into liquid state. So other processes you can see they all are chemical. So B and C will be the answer for this part D. Last one, E, is caused by gas particles colliding with each other. Now they are saying it's caused by gas particles colliding with each other. It's diffusion, which involves the movement of particles from higher concentration to lower concentration. So answer must be B here. Moving to next question, question number 2. This question is about atomic structure and the periodic table. A, define the term nucleon number. A nucleon number is the total number of protons and neutrons present in the nucleus of an atom. So you'll write total number of protons and neutrons in the nucleus of an atom. Part B, state the connection between the number of occupied electron shells in an atom and the period number of that element. So you have to state the connection between the number of occupied electron shells in an atom and the period number of that element. So they are same. These are the periods, you know that. Period number 1, and here period number 2. So periods 1, 2, 3, 4, 5, so on. And the connection is that they both are same. First period mean of 1 occupied electron shells. Second period means 2 occupied shells. So you write same. They are same. C. Write the electronic configuration of the following atom and ion. You know, atom, it must be neutral particle, does not carry any charge on it. So Si in this case is neutral. In order to write the electronic configuration, we should know the number of electrons. And for number of electrons, look at the proton number. Here's the proton number. It must be having 14 electrons. So you write 2, 8, 4. This will be the final electronic configuration of Si. What about Cl minus? You see there is a charge on Cl minus, which indicates it must be having 1 extra electrons besides its normal number of electrons. So now let's look at the proton number of this Cl minus. It's 17, which means it must have 17 electrons. So you'll add 17 plus 1. This will be the total number of electrons in Cl minus. So I will write 2, 8, 8. Part D, complete table 2.1. Here's table 2.1. We have atom or ion. In the first one, we are having Na. Proton number and nucleon number are given. Number of protons is filled. What about number of neutrons? In order to get the number of neutrons, you have to subtract number of protons from number of neutrons. So 23 minus 11. It must be 12. What about number of electrons? Number of electrons and protons are same for a neutral atom, and there is no charge on Na. So it must be having same number of electrons. So 11 will be the number of electrons for this Na. What about F minus? Number of protons and neutrons are shown. We have to write the number of electrons. If it's carrying minus charge, it means it must be having extra electron, and minus mean 1 extra electron. So you will add 9 plus 1. So 10 will be the electron for this. Now what about the third one? Number of protons, number of neutrons and electrons are given. We don't know whether it's an atom or ion, but looking at the number of protons and electrons, we can easily predict it must be an ion carrying plus 3 charge, because the difference between 31 and 28 is of 3. It's having 28 electrons, not 31. 31 protons and 28 electrons, which means that 31 minus, you have to minus 28. So it must be carrying plus 3 charge. So I will write plus 3 here. For the element, I have to look for the number of protons in the periodic table. 31 is the number of proton, or proton number of Ga. Ga is gallium. It's in group 3. You see 31 here. So I will write Ga here, and here I will write 31. And for the number of neutrons, for the number of for the nucleon number, you have to add number of protons and number of neutrons. So 31 plus 38, 69. So it must be 69 in this case. Moving to next question. Next part, E. A sample of helium, Tl, contains 2 isotopes TL 203 and TL 205. 1. Define the term isotopes. Now, isotopes are the different atoms of the same element with different number of neutrons. There's the same number of protons, but different number of neutrons. So you write different atoms of the same element with same proton number, but different number of neutrons or nucleon number. Different number of neutrons or nucleon number. Part 2, the relative abundance of TL203 and TL205 is in the ratio 3:7. Calculate the relative atomic mass of thallium in the sample to 1 decimal place. Now what I'm going to do, I'm considering this ratio as percentage. If you add 3 plus 7, it will become 10, which means we have, I'm writing the data, 30% TL203 and 70% TL205. Now let's take 30% of 203. So I will multiply 203 by 30 and divide it by 100. Plus, in order to calculate the percentage of this 205, we have to multiply 205 by 70 and divide it by 100. Sixty point nine. 60.9 for the first one. For the second one, 205 multiplied by 70 and divided by 100, 143.5. Adding up these values, .150 I will add it again, 60.9 plus 143.5, 204.4. 204.4. This will be the final answer. Part 3 suggests why these two isotopes have identical chemical properties. Chemical properties are depends on the number of electrons, or you can even write electronic configuration. So they have same number of electrons, same number of electrons, or same electronic configuration. Number 3, copper 2 sulfate has a formula CuSO4. Aqueous copper 2 sulfate is a blue solution. A sample of aqueous copper 2 sulfate is made by adding excess copper 2 oxide CuO to hot dilute sulfuric acid H2SO4. A. Complete this symbol equation for this reaction. Include state symbols. So this reaction produces copper 2 sulfate and water. Water must be the last product and it will be in the liquid state. Copper 2 oxide, it must be in the solid state. So I will write S here in case of CuO. For H2SO4, I will write AQ. You know that acid. For acid, water is necessary. And it's written aqueous. It's written dilute sulfuric acid. CuSO4 is aqueous copper 2 sulfate. So we must be having AQ here also. Part B, state one observation which shows that copper 2 oxide is added in excess. If it's in excess, then there won't be any more solid dissolving in the solution. So you'll write no more solid dissolves. No more solid dissolves. Part C. Describe how aqueous copper 2 sulfate can be separated from the reaction mixture. So we'll go for filtration. In order to remove the excess copper 2 sulfate, write filtration. This will be the correct spelling of filtration. Moving to next part, which is part D. Crystals of hydrated copper 2 sulfate can be obtained from aqueous copper 2 sulfate by crystallization. Number one, state what is meant by the term hydrated. When water is chemically combined with the substance, or it contains water of crystallization. And the substance is chemically combined with water or contain water of crystallization. Part 2, write the formula of the hydrated copper 2 sulfate. It exists in the pentahydrate state. So you will write CuSO4, 5 molecules, penta means 5, 5 molecules of water will be attached. So I'm going to write 5H2O. 3. Describe how this crystallization is done. So in the first step, you have to heat the solution. Heat the solution to saturation point. Then you will cool it down. Cool it down. You can't dry it because in this case, it will lose its water of crystallization. Moving to next part, which is part E, aqueous copper 2 sulfate undergoes electrolysis using graphite electrodes. A. State why aqueous copper 2 sulfate conducts electricity. So it's a liquid. So the liquid that conducts electricity, it's due to the presence of mobile ions. So you write mobile ions. Part 2. Give 2 reasons why the electrodes are made of graphite. First one, it must be the common reason for these electrodes, that they are conductor, conducts electricity. Conducts electricity. Second reason must be related to its reactivity, as it is unreactive or inert. Unreactive or inert. Part 3. Describe how the appearance of the electrolyte changes during the electrolysis of aqueous copper to sulfate. So when this electrolysis continues, what will happen to the appearance of the electrolyte? As there will be loss of copper 2 ions from the solution, so that definitely the color becomes light blue as electrolysis progresses. Becomes light blue. Number 4. Describe what is seen at the cathode during the electrolysis of aqueous copper to sulfate. Now, copper will get deposited at cathode. Copper deposits and copper is brown or pink in color. So you write pink or brown solid. Pink or brown solid. Number 5, write the ionic half equation for the reaction at the anode. At the anode, OH negative ion will move to release oxygen gas and water. This will be the equation. OH minus aqueous, oxygen is produced, O2 gas plus water, H2O liquid, and there's oxidation, which means there's a loss of electron, so I will write E minus. Let's balance this equation. In order to balance oxygen, I need to write 4 before OH, then this water will become 2 moles, and there will be 4 moles of electron lost at anode. Number 6, state 2 differences seen if the electrolysis is repeated using copper electrodes instead of graphite electrodes. Now, first difference must be related to the electrodes. So, cathode will gain in mass. You can write any two from this. Cathode will gain mass, anode dissolves. You won't see any bubbles at the anode. And also, the color remains same or constant. Because at cathode, the copper ions will deposit as copper. And in order to compensate the loss of copper plus 2 ion in the solution, copper anode dissolves. That's why the color remains same. So we'll write any two from these. Color remain same or constant. Anode dissolves. Cathode gain in mass or cathode gain in mass or no bubbles at the anode. Moving to next question, which is question number 4. When magnesium nitrate is heated strongly, magnesium oxide is formed. A. The equation for this reaction is shown. 2 Mg NO3 whole twice gives 2 MgO plus 4 NO2 plus O2. 1. State the change in oxidation number of nitrogen N in this reaction. So Mg is attached with the nitrate ion. So first of all, I need to look at the oxidation number of nitrogen in the nitrate ion, which is on the reactant side. So here's nitrate ion. So if you look at the position of nitrogen and oxygen, oxygen is on the right hand side, then nitrogen. So it must be carrying minus oxidation number, which is equal to its valency -2. So the charge on nitrate ion is minus nitrogen. Let's consider it as X plus 3 atoms of oxygen. 3 multiplied by -2, which is the oxidation number of oxygen, is equal to -1. So X minus 6 is equal to -1, or X is equal to -1 plus 6, which becomes +5. So initially it must be +5. What about in NO2? NO2 is a neutral compound. So there isn't any charge on NO2 overall. So I write 0. Let's consider this nitrogen again as X plus 2 atoms of oxygen, which will be multiplied by the oxidation number of oxygen, which is -2 in this case, is equal to 0. X minus 4 is equal to 0, or X is equal to +4. So it's changing from +5 to +4. Number 2, identify the element which is oxidized in this reaction. So if you look at the oxidation number of oxygen on the reactant side, it's -2. What about the product side? 2MgO. Magnesium is a metal. So oxygen again will carry -2 as its oxidation number. NO2 we have already discussed, -2. What about in O2? It's 0. So if you look at this, -2 is changing to 0, which means it's getting oxidized. Oxidation number increased. So you write oxygen here. Oxidation number of magnesium remains same on the both side of the equation, +2 on the reactant side, +2 on the product side. So oxygen is the only element which is oxidized in this reaction. Number 3, calculate the volume of NO2 gas at RTP formed when 7.4 gram of MgNO3 whole twice is heated. Use the following steps. First of all, we need to calculate the MR of MgNO3 whole twice. So for Mg, where is Mg? Here is Mg. Relative atomic mass is 24, and it's 14, oxygen, it's 16. So 1 magnesium, we'll write 24 plus how many nitrogen? 2 nitrogen. So 2 will be multiplied by 14. What about oxygen? 2 3 is 6, 6 multiplied by 16. So this will become 148. Calculate the number of moles of MgNO3 whole twice used. So you simply have to divide the mass by the MR, 7.40 divided by 148. So we'll get 0.05 more. Determine the number of moles of NO2 formed. So what's the relation between MgNO3 whole twice and NO2? It's 2 to 4. MgNO3 whole twice gives NO2. The relation is 2 to 4. 2 moles giving 4 moles of NO2. Therefore, 0.05 moles give X moles. Do the cross. It becomes X is equal to 4 multiplied by 0.05 and divided by 2. So you need to multiply 2 by 0.05, which becomes 0.1 mole in this case. Now calculate the volume of NO2 gas in centimeter cube at RTP. They are asking answer in centimeter cube. You know, at RTP, it must be 24,000 centimeter cube. 1 mole of any gas occupies a volume of 24,000 centimeter cube. So we multiply number of moles by volume at RTP. It becomes 0.10 multiply by 24,000. Answer becomes 2,400 centimeter cube. Next part, magnesium oxide, MgO, is an ionic compound. Complete the dot and cross diagram in figure 4.1 of the ions in magnesium oxide. Give the charges on each of the ions. In magnesium oxide, which is MgO, magnesium has lost electrons and oxygen has gained electrons. If you look at the position of magnesium oxygen, where is magnesium? Magnesium is in group 2. Here's magnesium, oxygen. It's in group 6. So magnesium will lose its 2 of its valence electrons, and on the other hand, oxygen will take up or gain those 2 valence electrons. The proton number of magnesium is 12. So it will lose 2 electrons. Now the number of electrons become 10 in this case. So it's left with 10 electrons now. 2 electrons are already shown. So I need to show 8 more electrons. 1, 2, 3, 4, 5, 6, 7, 8. As it has lost 2 electrons, it will carry +2 charge here. What about oxygen? Oxygen is in group 6, which means it got only 6 valence electrons. And it's also in, looking at the proton number of oxygen, it's having 8 electrons in all. So 2 electrons are already shown. So I'm showing other 6 electrons. 1, 2, 3, 4, 5, 6. Now the 2 electrons it has gained is coming from magnesium. So I'm going to show it on the top. Here are the 2 electrons and place -2 charge on the right hand side. So this will be the final answer. C. Oxygen is a covalent molecule. Complete the dot and cross diagram in figure 4.2 of a molecule of oxygen. The inner shells have been drawn. Both the oxygen atom, they are in the group 6, which means they are having 6 valence electrons. And it also means it need 2 electrons. 2 electrons are needed by each oxygen atom to complete their valence shells. And they are going to share 2 of their valence electrons with each other. Sharing 2 electrons from each oxygen atom. So for the right hand side, we have 1, 2, 3, 4, 5, 6. For the left hand side, we have 1, 2, 3, 4, 5, 6. So this will be the final dot and cross diagram for this oxygen molecule. Moving to next question, that's question number 5. Hydrogen is the first element of the periodic table. A. Hydrogen is used in fuel cells to produce electricity in vehicles. 1. Name the substance which combines with hydrogen in a fuel cell. So it's oxygen which combines with hydrogen in the fuel cell. Number 2, give one advantage and one disadvantage of using fuel cells instead of gasoline in vehicle engines. So you can write any one of these advantages. So it's fuel efficient, which means it produces more energy than non-renewable fuel, and water is the only product. No carbon dioxide is produced in this case. You can write any one of these advantages. Fuel efficient. Water is the only product. No carbon dioxide produced. What about disadvantages? Disadvantage, we need high pressurized tanks to store hydrogen. Hydrogen is also highly flammable. Heavy tanks needed, and there will be fewer hydrogen filling stations. So you can write any one from these. High pressurized tanks needed to store H2. H2 is highly flammable. Which means difficult to handle or store. Heavy tanks needed. You can even write fewer hydrogen filling stations. B. Hydrogen gas can be made from petroleum by a two-step procedure. Step 1, petroleum is separated into different components. Step 2, large molecules obtained in step 1 are converted into smaller molecules, including hydrogen gas. 1. Name the process used in step 1. It's fractional distillation. Fractional distillation is done in order to get the different fractions from petroleum. And they are asking about step 2, which is cracking, which involves cracking of large molecules into smaller and useful fractions. C. Organic compounds contain hydrogen atoms. Calculate the number of hydrogen atoms in 44 grams of the ester methyl propanoate, CH3, CH2, COO, CH3. 1 mole of CH3, CH2, COO, CH3 contains 6.02 into 10 to the power 23 molecules. Give your answer in standard form. So first of all, we need to convert this 44 gram of ester, which is methyl propanoate in this case, into moles. For this, we need MR of methyl propanoate. MR of CH3, CH2, COO, CH3. So we have 1, 2, 3, 4 atoms of carbon. We'll multiply it by AR of carbon, which is 12. For hydrogen, it's 1. Oxygen, it's 16. How many hydrogen there? 3 plus 2, 5. 5 plus 3, 8. So 8 will be multiplied by 1 plus 16 multiplied by 2. This will become 88. Now moles of methyl propanoate. This is obtained by dividing the mass by MR. 44 divided by 88, and it becomes 0.5 moles. Now they are saying calculate the number of hydrogen atoms. In order to calculate the number of hydrogen atoms, we need to calculate the moles of hydrogen atoms first. So here's methyl propanoate, CH3, CH2, C double O, CH3, and here is hydrogen atom. The mole relationship is 1 mole of methyl propanoate. It contains 8 moles of hydrogen atoms. Therefore, 0.5 mole must be having X moles of hydrogen atoms. So we will get X is equal to 8 multiplied by 0.5, which becomes 4 moles. We have 4 moles of hydrogen atoms. Now, in order to calculate the number of hydrogen atoms, we need to multiply this 4 by Avogadro number, which is written 4 multiplied by 6.02 into 10 raised to the power 23. So the answer will be 2.408 multiplied by 10 with the power 24. So this will be the final answer. Part D. For each of the homologous series shown, name a member that contains 6 hydrogen atoms. Now they are saying 6 hydrogen atoms. They didn't mention the number of carbon. So for the alkanes, we should know the member which contains 6 hydrogen atoms in all. For alkane, the general formula is CnH2n plus 2. Which means if I will take the value of 2, n as 2, I will get 6 hydrogen atoms. N must be 2 here. N must be 2 in order to have 6 hydrogen atoms, because 2 multiplied by 2 is 4, 4 plus 2 is 6. So the name for this member must be ethane. What about alkene? General formula is CnH2n. In order to get a hydrogen as 6, we must have N 3. Because 3 multiplied by 2 is 6. So it must be propene. The third member, in fact, which is the second member in case of alkene, it's propene. What about alcohol? CnH2n plus 1 OH. If the value of N is 2, then the hydrogen must be 6, because 2 multiplied by 2 is 4, 4 plus 1 is 5, 5 plus 1 is 6. So it must be ethanol in this case. In case of carboxylic acid, the general formula is CnH2n plus 1 COOH. And must be 2. Because 2 multiplied by 2 is 4, 4 plus 1, 5, 5 plus 1, 6. So N must be 2 here again. What about the name of this member? If you take N as 2, it becomes C2H5 COOH. There will be 3 carbon atoms, which means it's propanoic acid. Propanoic acid. Part E. Unsaturated alkenes are converted into saturated alkanes by reaction with hydrogen gas. Number 1, state why alkenes and alkanes are hydrocarbons. They contain hydrogen and carbon atom only. Contain hydrogen and carbon only. Moving to next part. State why alkenes are unsaturated. Alkenes have carbon-carbon double bond. So you write contain carbon-carbon double bond. Contain carbon-carbon double bond. Part 3. Name the catalyst needed to convert alkenes into alkanes. The reaction is hydration. Sorry, we are converting alkenes into alkanes. It's a hydrogenation reaction. Addition of hydrogen. And the catalyst used in this case is nickel. So I'll write nickel here. Number 4. Explain why the conversion of alkenes into alkanes is an addition reaction. Only a single product is produced, so you'll write only one product is formed. Moving to last question, which is question number 6. Question number 6. Natural polyamides are polymers made from amino acid monomers. A. State the type of polymerization reaction that occurs when natural polyamides form. It's condensation, because it involves the release of a simple molecule like water. B. State the term given to natural polyamides. These are known as proteins. They have polyamide linkages, amide linkage. That's why they are known as polyamides, natural polyamides. C. An amino acid is represented as shown in figure 6.1. Figure 6.1. Complete figure 6.2 to show the general structure of an amino acid. Show all of the atoms and all of the bonds in the functional groups. So on one side you must be having NH2. It must be like that. And one side you have carboxyl group, which is C double bond O, O bond H. And there must be R group on the top. R can be any alkyl chain. D. 3 different amino acids are represented as shown in figure 6.3. Is figure 6.3, we have amino acid A, amino acid B, amino acid C. Complete the diagram in figure 6.4 to show the part of the structure of the natural polymer that forms when the 3 amino acids A, B, C, and D combine. Show all of the atoms and all of the bonds in the linkages. What you will do, you simply need to remove OH from carboxyl group and 1H from NH2, that is amine group. Then join it. For the left hand side, we have N bond H. On the right hand side, we have C double bond O. In this way, you're going to show the linkage for all of these. So on the right hand side, again, we have NH, CO, NH, CO, so on. This will be the final answer. E. A mixture of the 3 amino acids A, B, and C can be separated and the amino acids identified using paper chromatography. Complete the equation for RF. In order to find the RF, what you need to do, divide distance traveled by the substance by the distance traveled by the solvent. So we have distance traveled by the substance divided by distance traveled by the solvent. Moving to next part. Part F, a sample of the mixture of the three amino acids A, B, and C is placed onto the baseline and a chromatogram is allowed to develop as shown in figure 6.5. The finished chromatogram is shown in figure 6.6. The amino acids A, B, and C are colorless. Water is used as a solvent. 1. Explain why the baseline is drawn in pencil. So pencil is insoluble. That's why we are using pencil. It's insoluble in the water. So we write pencil is insoluble. Next part, state the type of substance used to make the colorless amino acids visible on the chromatogram. We need to use locating agent. Part 3, explain why in figure 6.6 only 2 spots are seen from the mixture of 3 amino acids. We have 3 amino acids, but we are seeing only 2 spots here. Spot number 1, spot number 2. So they are asking the reason for this. Both are 2 of the amino acids have same RF value. So you will write same RF value. That's why you will see only 2 spots. Number 4, suggests how the experiment can be changed to separate all 3 amino acids. Definitely you have to use different solvent. So you write use different solvent. That's all for this video. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.